We're going to use matrices and determinants to organize information. And if you haven't used these words recently, we'll just give you a quick introduction. A matrix, in its simplest form, is a rectangular array, a table of information. A determinant is a particular calculation on a square matrix of numbers. Here we give examples of how determinants are defined recursively. If you have the table of numbers A, B, C, and D, the determinant is defined to be AD minus BC. That's A times D minus B times C. Look at how you multiply by crossing out the row and column that contains the A, and the remaining submatrix, kind of a 1 by 1 matrix, D, you multiply A times D. And then going across the top row, cross out the row and column that contains B. The remaining submatrix is C. So we write B times C. Notice we use a minus sign in front of the B times C because what we're picturing is a checkerboard pattern of pluses and minuses on the matrix. These pluses or minuses become part of the coefficient when we multiply an entry times a submatrix. Let's do a demo with a 3 by 3 matrix. So we begin with A, crossing out row and column, times the matrix EF HI, the remaining submatrix. Then we look at B. We cross out the row and column there. It's a bit messy. Let me repair that matrix. You multiply by the submatrix. Imagine we cross out the B row and column. DFGI. And the last entry across the first row, C, multiply C by the submatrix DEGH. That is, we crossed out the row and column of C and multiplied by the determinant of the remaining 2 by 2 submatrix. And we know how to calculate that. Finally, we add the plus or minus pattern that is expressed by the first row in this matrix. So we say plus A minus B plus C. So the result is A times EI minus FH minus B times DI minus FG plus C times DH minus EG. So we continue recursively in this pattern for any size square matrix. We're not going to work on 4 by 4 matrices in this class, but if we did, we'd quickly write across the first row, A times the remaining 3 by 3 minus B, think of the checkboard pattern, times the remaining 3 by 3, plus C times the remaining 3 by 3, minus D times the remaining 3 by 3 matrix determinant. You can see this grows in work very quickly because to evaluate a 4 by 4 determinant, you have to do 4 3 by 3s. To evaluate a 5 by 5 determinant, you have to do 5 4 by 4s. So determinant calculation is not always trivial. I'm just writing in the submatrices here. Finally, D times EFG, IJK, MNO. Matrices are commonly expressed with square or round brackets. But when we do determinant, we kind of use the absolute value bars or bars without the head and feet. The determinant doesn't make sense for a matrix that's not square because I can't apply this recursive property. But if I asked you to find the determinant of 1, 7, 6 minus 12, let's be very careful with your signs. It's 1 times minus 12. Subtract minus 7 times 6. That's adding 42 or 30. Practice taking determinants, practice doing them carefully, correctly, and quickly. Your calculator also evaluates determinants for you.